Hello everyone, and in this video we are going to go over the turbofan that I've been putting together for an experiment to run on a 6S. I believe this is a 3060 or the 4060. It's right here. You can take a look at it. It's sort of all rubbed off, but you can kind of see what's there. Okay, there you go. Anyway, I've made an adapter for this to run into the back of this part, which is where the cone will go on after I put on the rear section that actually holds the motor, and then the shaft will go into here and glue into place, and that will basically be how I turn the motor. Now, there's a few things that I noticed about this. This being designed as an open sort of cutaway desktop model, there wasn't a lot of, I mean, in the file, dimensionally it works perfectly, but the one thing that you always have to consider when you're dealing with things like these, especially with FDM printing, is the extrusion on both sides of the actual model wall. Now, if you have your printer configured to where it knows that it's got a 4mm or a 0.4 millimeter nozzle, and there's going to be some squish of at least 0.2 on either side of the nozzle, or 0.1, then you can pretty much make sure that these are accurate in the sense to where you have compensated for that overprint because of the actual extrusion. Because what I noticed is that I ended up with a gap, even though the model itself is actually lining up perfectly in Fusion. You still have an extrusion problem where you get a gap. So I wanted to know exactly how much that extrusion problem was. So I found out, and I printed the strip to close the model completely. Now this will be completely sealed. I'm not too concerned with the overall outward looking quality of the case, because the idea is to make sure that it's just sealed. So after a little bit of playing around in Fusion, I figured that part out. And what the next step is going to be is going to be putting in the bearings and things like that after I finish the printing. I'm doing the stators right now for the rear section, and then I'll be doing the blades for the rear section, and then the nozzle. There is a variable speed nozzle that I can put on, but for the initial testing purposes, I'm going to use the nozzle that comes with this original turbofan model, but with the second compressor stage. So we're not using the large fan in the front that came in the original model. Now, the bearings that I'm using are PGN high RPM bearings that'll go here and here. I found out what size they were, and I ordered them, and they're actually a lot cheaper to get them that way. And the hardware I just picked up on Amazon, the screws and the nuts, and I use nylon locking nuts rather than just regular nuts that the model called for in the kit, because you can get the model, and then where the model is, you can get different sites here and there, and you can actually pick up the hardware for it, but they're not locking nuts. I wanted the locking nuts for the simple reason that I want to try and make this as airtight as possible. So without having to CA glue these two pieces together for the sake of it being airtight, I'll probably use a RTV silicone gasket maker and kind of just put it around, a thin layer around the bottom of where they come together. Not enough to offset any of the dimensions, because dimensionally it's designed to be a specific length, and I don't want to mess with that at all. But putting in the PGN bearings that are high RPM and they're greased will definitely help, for sure. What we're going to test basically is how many RPMs can they actually take before they fail. Now, this is printed at, I believe, standard resolution of 0.20. Most of the fans inside the actual compressors and the stators were done at 0.0 0.08 millimeters, so actually fairly high resolution. But the idea was just to make sure that I had good layer adhesion, so thin up the layers, still extruded at the same heat, make sure that everything is as clean as possible. And you can see that everything came out fairly clean. There's not a lot of layer lines. There is a seam, but that's negligible. It may offset the weight by like micrograms, if anything, but it's not going to make much of a difference with the RPMs I'm going to be running, because the point of this here is to run this to failure to see when these fans fail, and it'll probably be this first compressor fan, the one that starts the whole thing off. So when we're not using the big one, we've exchanged the main fan that sits in the front of the original model with an extra compressor set and this fan here as a driver. And so that's going to kick off the whole thing. I'm hoping, fairly hopeful, that I'll get maybe halfway through the throttle before I start seeing too much flex in these blades here, in which case I will try and find, obviously after this experiment is done, I want to do this in a more rigid material, possibly an SLA type material, something roughly the integrity of an injection molded plastic EDF. To go to an extreme, I could have it machined or CNC'd or 3D printed in metal, but realistically, the idea is, can we do this with an FDM printer? And I know I had some people, looking at the Dragon I was doing over here and saying, oh, well, I didn't even know that was FDM. That's what I love about the X1 Carbon. Bamboo Labs X1 Carbon and Bamboo Lab Filament, they have the tabs inside the spools, so it makes it easier for the machine to already know the preset of the material that it's using. The quality, even with a 0.4 nozzle, is phenomenal when it comes to detail on most of the prints that you do. If you're doing smaller figurines, I would move to a 0.0 or 0.2 millimeter nozzle instead of a 4. But right now I'm sitting at 4. I was using 6 before when I was using it to print larger airfoil structures and things like that. Especially for the Javelin, because that was necessary. It saves on print time. The only issue was, depending on how you slice the model in Bamboo Studio, you'll get those rounded corners because of the nozzle size. So I could go completely off the map and just do the whole thing in 0.2 and have absolutely no gaps whatsoever, and it'd be really clean, but it would take a very long time to print, something along the lines of the traditional print speeds that most people are used to. So you would trade off the print speed of the Bamboo Lab X1 Carbon for the dimensional accuracy and detail that you would get out of a 0.2. But I mean, if you're setting it to print overnight, who's going to care, right? So anyway, back to this model. The point is, I may do this in a nylon material if I get a failure early on the PLA. Something a little bit stronger, but I may do it in a 0 or a 0.2 millimeter nozzle, just to see if I can get a better layer adhesion, more detail, more wall loops, and a little bit more strength. So if you have any suggestions on materials that you think I should use for something like this, then leave it in the comments. Subscribe, share it with your friends, get their ideas, their opinions. And fairly soon here, we are going to be running this to failure. I'm going to have 2 camera views set up. I'll have one on the back side over here. I'll have one at the front of the turbine. I'm going to use the rig that I have already set up for the Javelin because I don't have an extra 80 amp, ESC laying around. That's D-shot. So everything's already programmed for these motors. So I'm just going to use one of the ESCs off the rig, plug the battery up, and then we're going to run this motor. I do have a plane mode that I transitioned, that I have on a transition switch, which will give me the full range of the motor's RPMs. So we're gonna, switch it to plane mode. Again, everything that goes in the Javelin isn't installed in it yet because I'm still waiting for the motors. So, I'm just gonna use basically its nervous system to power this for the test. So stay tuned for that because it's going to be interesting. I want to see the effect of having the high RPM bearings in there. I want to see the thrust potential that I can get out of it, the max RPMs we're looking at before we have any catastrophic failures within the fans. This one having longer blades, I would see failing first, if anything. These have much shorter blades, but they're roughly the same dimensions. So there's not a lot of flex that's going to happen here. So it may be subjected to some torque from the compression of the air as it compresses through the rest of the motor, but only time will tell. I think these larger diameter blades will do better as far as being on the actual spool, as opposed to the actual drive fan, which is a little bit more exposed surface area. There's a lot more there for flexing, and since we're going with the actual dimensions of the model, I haven't thickened these up or anything like that. So that's going to be, let's run it. That'll probably fail first. Could be wrong, but it might be what fails first. And that's one of the reasons why I'm going with the sealed bearings, because it's not a desktop model at this point. At this point, we're testing a 3D printed turbofan to see if we can get more thrust, because the EDF out of this engine, or the actual EDF casing in the fan with this engine, was producing about 5 pounds of thrust. Now, we're going to run this thing to test RPMs. I don't know that I'll have a rig set up to test the actual thrust that I may produce with this. But after I run the initial RPM test and I see where my safe limits are, then I will finish the variable nozzle at the rear, or I will not, and I'll just run it with the standard one. And we'll set up a rig where I can test to see what thrust I'm getting off of here. So this does have a nose cone that sits out front that I can build a stand off of, that I can put up against a scale, and then it has a stand that it'll sit on, and we'll figure out a way to do it. The easiest way to do it would be straight up and down and let it sit on the scale and then zero it out, but I don't want to do that. What I want to do is I want to set it on its side and then have it push forward. So, because realistically you're talking about, if you're setting it straight up and down and then tearing it out, you got gravity on your side at that point. I think a vertical, not vertical, but a more horizontal test of the engine is probably going to be a bit more accurate. So even if there is a little bit of drag from the stand that it sits on, it's going to give me that cushion of error. So I can say, okay, if it's producing 15 pounds of thrust sitting vertically, and we know there's drag, there's not going to be a whole lot of drag, but we know that it's going to be fairly accurate. The vertical test is good, it works, but it's just, I think, gravity's on your side when it comes to that. Not only are you pushing down, but you don't have any resistance from the drag of the environment. So that's what we're going to try and do, is get all those variables into play so that we can get a fairly accurate depiction of what kind of thrust ratio we're looking at. So yeah, that's pretty much where we're at on that. You can expect to see this probably within the next week, the RPM test. We will have the 2 camera angles, like I said, and I will be controlling it from far enough away. I'm going to do it right here on the desk. So I'm going to have to like move anything over this way that's going to get blown off, like the keyboard, the mouse, and stuff like that. But until the garage is finished with its retrofit, then this is my shop, and then of course the back corner of the living room where I have my other table set up where I'm assembling everything. But look forward to that. I think that's going to be fun. I mean, who's not anxious to see this spinning at ungodly RPMs, right? I mean, that's going to be fun. Even if it fails, which we know it's going to, because that's what I'm going for. It's just going to be, it's going to be beautiful. And I'm realizing I don't like tree supports on flat bottom. I just don't. They don't work out too well. But yeah, this is going to be fun. So, as I break it. Anyway. So stick around, and I will let you all know with a short how close we are to doing an actual RPM test on this motor. On the first, probably not the first, but as far as I'm concerned, the best, EDF engine. Created with an FDM printer. A turbofan. You know, one that will go as fast as I want it to, or explode immediately. Either way, it's going to be entertaining. So, thank you all for watching, and stay tuned.